Hello and welcome. In this video, we're going to talk about how to solve first order homogeneous differential equations. Now, the very first thing you need to know is how to identify an homogeneous differential equation. Now, in the previous video, we solved a problem that looks like this. And we said that we can solve this problem using separation of variables to have variable y standing alone and variable x standing alone, and then integrate both sides and then solve. It becomes easy to solve and get our answer. Now, what if we have a problem that looks like this? Taking a look at it, it cannot be re-expressed to have variable x standing alone and variable y standing alone, right? So we cannot solve this using separation of variables. So how do we solve this? Now, the next thing for you to do is check if this equation is an homogeneous differential equation. So for me to check if this is an homogeneous differential equation, what I simply do is to check the degree of each terms. Okay, so taking a look at x, the degree of x is 1. Taking a look at 3y, the degree of 3y is 1. Taking a look at 2x, the degree of 2x is 1. So this is an homogeneous differential equation. What if I have something like this? How can I check if this is an homogeneous differential equation? I take a look at 2xy. The degree of x is 1, the degree of y is 1. So the degree of 2xy is 2. The degree of 3y squared is 2. The degree of x squared is 2. The degree of 2xy is 2. So this is an homogeneous differential equation. So how do we actually solve these differential equations? Let's solve this one. Now, the first step is to let y equals vx, where v is a function of x. So v is a function of x, and we are assuming, or we are letting y to be equal to vx. Whenever you're solving an homogeneous differential equation, this is always going to be your first step, right? Letting y equals to vx. So the next thing is to differentiate y with respect to x. Okay, so differentiating y with respect to x, we have a function of x and we have another function of x. So we are using product rule, right? So drop this, differentiate this, 1 plus drop this, differentiate v, you have dv dx. Okay, so when we differentiate vx, we're going to have v plus x dv dx. So let's take this as our equation 1. Now, the next thing to do is to substitute y into this dy dx. Substitute vx into dy dx. Alright, so from the original question, dy dx is going to be equal to x plus 3vx divided by 2x. Alright, we can simplify this, right? X is common, so we're going to have x into 1 plus 3v divided by 2x. So x cancels x, and this becomes 1 plus 3v divided by 2. So this is our equation 2. This is our equation 2. So this is dy dx, this is dy dx. We can equate equation 1 and 2. Alright, so we're going to have this as 1. Okay, let's equate equation 1. So v plus x dv dx is going to be equal to 1 plus 3v over 2. Okay, so we can simplify this, right? So x dv dx is going to be equal to 1 plus 3v over 2 minus v. Okay, we can still simplify. X dv dx is going to be equal to, let's do LCM, 2, 1 plus 3v minus 2v. right? So x dv dx is equal to 1 plus v over 2. Now that we have simplified it to this point, okay, we have dv, we have dx, we have variable v, we have variable x. We can use separation of variables. Okay, so the goal here in making y vx was to simplify the y dx in such a way that we can use separation of variables. Okay, so now let's use separation of variables. So I have x dv dx equals to 1 plus v over 2. I can cross multiply to have 2x dv dx equals 1 plus v. I can have 2x dv equals 1 plus v dx, but I want x and the x to be together and v and dv to be together. So let me rearrange. So I'm going to have 2 over 1 plus v dv equals to 1 over x dx. Alright, so now we can solve this, right? So integrate both sides with respect to our variables. So when I integrate to 1 plus v, I'm going to have 2 ln 1 plus v. And when I integrate 1 over x, I'm going to have ln x plus c. So in order for me to easily simplify this, I can ensure that all the terms are written in terms of logarithm. Okay, so it will be easier for me to simplify it. So I can write this as 2 ln 1 plus v equals ln x plus, let's replace this constant with a value, say ln a. Okay, now I can rewrite this as 2 ln 1 plus v equals, now simplifying this logarithm, this becomes ln ax. Alright, from the laws of logarithm. I can also simplify this from the laws of logarithm. The 2 becomes the power. So ln 1 plus v squared equals ln ax. Okay, from here I can conclude that 1 plus v all squared equals to ax. At this point, we are 90% done with our work. We have simplified to the point that we can now substitute, right, and bring in y into the equation, because we want to get the value of y. We want to solve the homogeneous differential equation to obtain y. Okay, so recall that you made y to be equal to vx, right? So v becomes y over x. So substituting y over x, it becomes 1 plus y over x all squared equals to ax. Now I can simplify this to have x plus y over x all squared equals to ax, and this becomes x plus y all squared over x squared equals to ax, and this becomes x plus y all squared equals ax cubed. We can leave our answer like this, and we can pick this as our final answer. Alright, so we are going to stop here for this video. In the next video, we are going to move on to linear differential equations using the integrating factor. Thank you very much for watching. Don't forget to like, share, subscribe, and comment if you have any questions. Goodbye.